Hi everyone. So today we're going to finish off the test revision. So we've got 2 more questions to do from the practice test. And then after that, I'll get to any more questions that you have about the test tomorrow. Okay, so last time we finished off question 3. So now we're on question 4 on indefinite integrals. Okay, so remember that this practice test has exactly the same format as your test on Wednesday. So your question 4 on Wednesday will also be indefinite integrals. I just changed it up a bit. Okay, so 4.1, we have the integral of 1 over 5 minus 4x, all of that squared, dx. Okay, so we can see that we've got 5 minus 4x in the denominator, and all of that is squared. So we've got this inside function of 5 minus 4x. So that gives us a hint as to what the u substitution needs to be. So in this case, we can say that u is equal to 5 minus 4x. So du is du by dx dx. So du is going to be minus 4 dx. Okay, but we've got a little problem here because our original integral has dx, but du is minus 4 dx. Okay, we don't want this minus 4 here. So we divide both sides by minus 4. So we have minus 1 over 4 du is equal to dx. And that's what we want. We want just dx here. So let's do the substitution. So this becomes the integral of the 5 minus 4x becomes u. So we have 1 over u squared, and dx will be minus 1 over 4 du. Okay, so that's our new integral that we need to solve. So let's do that. The minus 1/4, we can take that out to the front. So we get minus 1/4, the integral of. Now, instead of 1 over u squared, we can write this as u to the minus 2. Okay, that's just going to help us in the next step when we do the power rule. So remember the power rule. We need to add 1 to the exponent, which will make it a minus 1, and then divide by minus 1. So we're going to have minus u to the minus 1. And remember to have your plus c. Okay, so whenever you have indefinite integrals, you have to add plus c. So always add plus c with indefinite integrals. Okay, because remember we're finding that family of antiderivatives. So we need to have the plus c. Okay, so now the minus from the minus 1/4 and the minus inside the brackets, they being multiplied, so that just becomes 1. So we end up with 1/4 u to the minus 1 plus c. But we don't want to leave our answer in terms of u. We want the answer in terms of x. So remember, u is equal to 5 minus 4x. So u is equal to 5 minus 4x. So our final answer will be 1/4 5 minus 4x to the minus 1 plus c. Okay, so that's after substituting back. Okay, are there any questions about this one?
Yes, sir.
Yes, yeah, what's your question?
Oh, sir, I do understand. I was mistaken on the
Sure.
square root of u.
Square roots of u. Where's that? Which part?
Sir, I got an understanding on these calculations.
Oh, okay.
Sorry.
Okay, no, sure. Okay, let's take a look at the next question. That's 4.2. So we have the integral of cos of x. So that's inside cos, and then times sine of x dx. Okay, so again, we're looking for that inside function. In this case, it's going to be this part over here, because that's what's inside cos. So we're going to let that be u. So if u is equal to cos x, then du will be du by dx. So du will be, the derivative of cos is minus sine. So we get minus sine x dx. Okay, but let's just check that. In the integral, we have sine x dx. For du, we have minus sine x dx. Okay, we don't want this minus here. So we multiply both sides by minus 1, and we get minus du is equal to sine x dx. And that's what we've got here. So minus du is sine x dx, and that's what we've got at the end of the integral. Okay, so let's do the substitution. So this becomes the integral of cos. Remember, this inside part is u, because u equals cos x. So that's going to be cos of u. And then sine x dx, that's minus du. Okay, so we can take the minus out to the front. So we have minus the integral cos of u du. The integral of cos is going to be sine. So we have minus sine of u, and don't forget your plus c. Okay, but we don't want the answer in terms of u. We want the answer in terms of x. So remember that u is equal to cos x. Okay, so minus sine of u will be minus sine of cos x. And then plus c. Okay, so we just substituted that back inside here. Okay, are there any questions about this? Okay, that's it for the indefinite integral part. The next two questions are on the net change theorem. So this is question 5 on the net change theorem. Okay, so for 5.1, the question says that we have a rod of length 3 and it has a density rho. So that's just what we write for density. At a position x is given by root x plus 2. And this is on the interval 0, 3. Because remember, the rod is 3 meters long. So this length is 3 meters. Okay, so what we want to do is find the total mass of the rod if we know the linear mass density rho. Okay, so remember, density is the derivative of mass with respect to the length. So if we want to undo that to find the mass, we have that the mass is going to be the integral from 0 to 3 rho of x dx. Okay, so we're just undoing that density calculation to get the total mass. Okay, so this is going to be the integral from 0 to 3 of root x plus 2 dx. Okay, so now we've got this root x. Remember, we like things in terms of powers. So we're going to change that to x to the 1/2. So that's the integral from 0 to 3, x to the 1/2 plus x plus 2 dx. Okay, now we can integrate this. So we add 1 to the exponent to make it 3/2. Divide by 3/2. That's the same thing as multiplying by 2/3. So we have 2/3 x to the 3/2 plus the antiderivative of x is going to be 1/2 x squared. Antiderivative of 2 is just 2x. And we're evaluating this between 0 and 3. Okay, so let's substitute the upper bound. So we're going to have 2/3 3 to the 3/2 plus 1/2 3 squared plus 2 times 3. Okay, if we substitute the lower bound, then we're just adding 0 because we're going to have 0, 0, 0. So we don't need to worry about that. Okay, so what is this going to give us? 3 to the 3/2 is going to be 3√3. So this will be 2/3 3√3 plus 3 squared, that's 9. So that's going to be 9/2. 2 times 3, that's going to be 6. Okay, so we're going to end up with 2√3 plus 9/2 plus 6. Okay, and if you want to combine all of this together, we get 4√3 plus 21/2. And remember, we're being asked to find the mass, so we need to put the units. So if the density is given by kilograms per meter, then this is going to be measured in kilograms. So remember your units. Okay, so in this particular case, we're asked to find the mass, so we need to put the mass units at the end. Okay, so remember you are getting marked on this final answer, so you have to put the units there. Okay, are there any questions about this? Okay, nice and simple. Let's take a look at the next one. This is 5.2. So we're given the velocity v of t is equal to 2t squared plus t minus 3 meters per second. That's how we measure velocity. What we want to do is find the total distance in the time interval from 0 to 3. Yeah. So find the total distance during the time interval from 0 to 3 seconds. Okay, yes, someone's got a question?
Yes, so with 5.1, I got 4 square root 27 plus 63 over 6. Like I times it by 3, if that's correct.
Oh, times by 3, so root 27. Yeah, so root 27, you can write that. That's
So
going to be
4,
square root 3 times 9.
Yeah.
And then root 9 is 3, so you get 3 root 3. So it's the same thing. It's the same thing here.
Okay.
Yeah.
Okay, no, I'm making sure.
Yeah, sure. So you can simplify down if you want, but I can just check on the calculator to see if you get the same answer. So I'm not too worried about your simplification. I'm more worried about this part here, if you can do the integral. So, if you can simplify it down, that's fine. I'm not too worried about that. This is where the marks are, up to here. Okay.
Okay, so.
Sure.
Okay, thank you.
Sure. Okay. Okay, let's carry on here. So we want to find the total distance during the time interval from 0 to 3, and we're given the velocity. Okay, so how do we go about doing that? Well, remember that distance is the integral of speed. So we've got the velocity. What we want now is the speed. So remember that the speed is the absolute value of the velocity. So we need the absolute value of 2t squared plus t minus 3. Okay, that will give us the speed. So we're given this function and we want to find where is it negative and where is it positive so that we can do this absolute value here. So let's find where this velocity is positive and negative. So we're going to have 2t squared plus t minus 3 is equal to 0, so that we can find those critical values. We can factor this as 2t plus 3, and then t minus 1 is equal to 0. And then this will give us t is equal to minus 3 over 2, t is equal to 1. Okay, so if we draw our number line for t, we're going to have 1 over here, which is minus 3 over 2. And over here, that's 1. And somewhere in the middle, we've got 0. Okay, so now we can see we've got a happy face parabola because the coefficient of t squared is positive. So the parabola is going to look, it's going to cut through here and look something like that. Okay, a happy face parabola. So on the left-hand side of minus 3 over 2, it's going to be positive. Between minus 3 over 2 and 1, it's going to be negative. And after 1, it's going to be positive. Okay, so now we know where the velocity is negative and where it's positive. So if we go back to here, we're interested in this interval over here. So from 0 to 1, it's negative. And from 1 to 3, it's positive. Okay, so now we can write out what the absolute value is going to be. So the absolute value of 2t squared plus t minus 3 is equal to, so in the first sub-interval from 0 to 1, it's negative. So we need to put a minus sign. So it's going to be minus 2t squared minus t plus 3 for 0 less than or equal to t less than or equal to 1. And between 1 and 3, it's positive, so we can just leave it. So 2t squared plus t minus 3 from 1 to 3. Okay. Are there any questions about this?
Yes, sir.
Yeah, what's your question?
So do we need to write a line?
The line.
Sorry.
Sorry? I didn't hear you. Yeah, what was your question? Sorry, I didn't hear you at the end there. Okay, let's carry on then. So we've got this absolute value now. So if we want to calculate the distance, remember the distance is the integral from 0 to 3, absolute value of 2t squared plus t minus 3. Okay, so the distance is the integral on the time interval of the absolute value of velocity. But we know that this gets split up into two parts, over here and over here. So on the first part, we have the integral from 0 to 1 of minus 2t squared minus t plus 3 dt. And then on the second part, we have the integral from 1 to 3 of 2t squared plus t minus 3 dt. Okay, so there's two parts to the function, so there's going to be two parts to the integral. Okay, so let's do the integral now. So for the first part, it's going to be minus 2 over 3 t cubed minus 1/2 t squared plus 3t from 0 to 1 plus. And then for the second part, we're going to have 2 over 3 t cubed plus 1/2 t squared minus 3t from 1 to 3. Okay, so I've just done the two integrals there. So let's substitute the upper and lower bounds. So for this first bracket, we're going to get minus 2 over 3 minus 1/2 and then plus 3. Okay, I've got a question here. Is it necessary to draw the parabola? No, it's not. Okay, so don't worry about that. All of this over here, let me just put here. All of this over here is side working. Okay, you don't need to draw any of this, but this part is important. You have to show me that you've split it up into two parts. Okay, so it doesn't matter how you get these intervals, as long as you show me the intervals here. So from 0 to 1, that's the first interval. From 1 to 3, that's the second. That's all you need to do. Okay, let's carry on. So we've done the first bracket, and then for the second, it's going to be plus. We need to substitute 3. So it's going to be 2/3 of 3 cubed plus 1/2 3 squared minus 3 times 3. Okay, that's substituting the upper bound. And then we need to minus substitute the lower bound. So that's going to be 2/3 plus 1/2 minus 3. Okay. And then we can simplify this. So this is going to be minus 4 over 3 from that and that. Minus 1, okay, from there and there. Plus 6, so 3 plus 3. Plus 18, plus 9 over 2, and then minus 9. Yeah, and then we can simplify all of this together, and we get 38 over 3 meters. Again, remember your units. Okay, so the final results here, that's going to be 2 marks. So you're going to get 1 mark for saying 38 over 3, and then 1 mark for remembering your units. Okay, and then of course, there's all the other marks above. Okay, but just this part over here, remember to put in your meters. Okay, there's 1 mark for that. Okay, are there any questions about this one? Okay, so this covers everything for that practice test. Got a question here. Question 4.2, there are 2 negative signs. Let's just find that, 4.2. Where's 2 negative signs? Okay, so we've got 1 negative sign here. That's from this minus du. And then remember that the integral of cos, so integral cos x dx, is sine x plus c. So we don't get another negative sign. So we just have 1 negative sign that carries down. Okay, the integral, just right here, the integral of sine x dx, that's minus cos x dx, cos x plus c. Okay, so don't forget which one gets the minus sign. Okay, any other questions about this practice test?
Sir,
Yes?
your final answer for 5.2 is supposed to be 103/6, not 38/3.
103/6. Let's just check that. So we have -4/3 -1 +6 +18 +9/2 -9. Let's do this slowly. So we have -4/3, 6 -1, that's +5, 18 -9, that's +9, +9/2. So we have -4/3 plus 9 plus 5. That's going to give us 14 plus 9/2. Let's make everything at the bottom 6. So timesing top and bottom by 2, we get -8/6 plus times by 3 plus 27/6 plus 14 times 6, that's going to be 74. Okay, and then that gives us 74 minus 8 plus 27. What did you say it was? 10.
Sir,
Yeah,
14 times 6 is 84.
84. Oh, I put 74. So, whoops. Okay. So what do we get here? What did you say it should be?
103/6.
103/6. Okay. Okay, that looks right. Where did I? Okay, I must have made an adding mistake there. Okay, so just check the adding with that. Okay, any other issues? Okay, so remember the scope for this test. So it's antiderivatives. Okay, then indefinite and definite integrals. Okay, then for that, we need to know FTC 1 and 2, U substitution, and the last thing is the net change theorem. Okay, so there will be a couple questions on each of these. Is there anything that you would like to go over again out of this list?
Sir, is it possible if you can do like another distance example?
Okay, sure. Yeah, I can do that. Okay, so this is part of the net change theorem bit. Sorry. Okay, so I'll just do a simple example here. So let's say V of t is going to be 3t squared minus 1. Okay, so remember that this is the velocity, so it can either be positive or negative. Okay, so I spoke about that before, but for finding the distance, we need the speed. So speed is equal to the absolute value of velocity. So in this case, it will be the absolute value of 3t squared minus 1. Okay, so to find the absolute value of something, we need to know where is it positive and where is it negative. So let's find that out quick. So we're going to have 3t squared minus 1 is equal to 0. So 3t squared is equal to 1. T squared is equal to 1/3. So t is going to be plus or minus 1 over root 3. Okay, so if we look at the timeline here, if we look at the timeline, if we're starting at 0, between 0 and 1 over root 3, we know that this is going to be negative. And then after 1 over root 3, we know that it's going to be positive. Okay, so that means we can rewrite this absolute value as minus 3t squared plus 1 between 0 and 1 over root 3. And it's going to be 3t squared minus 1 from 1 over root 3 onwards. Okay, so let's say we're trying to find the distance traveled between 0 and 1 second. Or let's say 2 seconds, so to 2. Okay, so we know that this velocity is now split up into 2 parts. The first part, we had to add the minus sign to make it positive, and the second part was already positive, so we can just leave it like that. So if we want to now find the distance, this is going to be the integral from 0 to 2, absolute value of the velocity, dt. So this will be the integral from 0 to 2, the absolute value. So between 0 and 1 over root 3, it's going to be this first part. So we're going to split this up. Oops, sorry. So this is the absolute value of 3t squared minus 1 dt. We now need to split this up into the 2 parts. Okay, so the first part is going to be the integral from 0 to 1 over root 3 minus 3t squared plus 1 dt. And then the second part is from 1 over root 3 up to 2. And that's the second bit here. 3t squared minus 1 dt. Okay, so that's the 2 intervals for the velocity. So let's do this first part. We're going to have minus t cubed plus t from 0 to 1 over root 3 plus, and then for the second part, we're going to have t cubed minus t from 1 over root 3 to 2. So for the first part, we're going to have minus 1 over root 3 cubed plus 1 over root 3. And then for the second part, we're going to have 2 cubed minus 2, and then minus 1 over root 3 cubed. So 1 over root 3 cubed minus 1 over root 3. Like that. Okay, so for this first part here, we're going to have minus 1 over 3 cubed, 27, so 1 over root 27, plus 1 over root 3, then plus 8, minus 2, minus 1 over root 27, and then plus 1 over root 3. Okay, so we can write this as 1 over 3 root, minus 1 over 3 root 3, and then we have another 1 over here. So we can make that a 2. And then 1 over root 3 plus 1 over root 3. That's plus 2 over root 3. And then 8 minus 2, that's 6. Okay, let's get everything to the same denominator. So if I times this by 3, I can times that by 3. So I have 6 minus 2. So that's going to be 4 over 3 root 3. And then plus 6. And then remember meters. You can leave it like that. You don't need to make it one fraction. Okay, so then that gives us the total distance. Okay, is that all right? Okay, so let's just go over this one more time here. So if I give you the velocity, remember that velocity can be positive and it can be negative. So what we want is the speed. So speed is the absolute value of velocity. So we need to take the absolute value of the function, and that's going to split the velocity function into two parts. One part where it was negative and one part where it was positive. Okay, so you do that. Just as a little note, remember absolute value of x is minus x if x is negative, and it's x if x is positive. So that's what we're using here. So the splitting up then goes into the integral. So if we are integrating the absolute value, then this gets split up as well. So we have the first part and we have the second part. And then we just evaluate the two integrals, add it together, and then we get our final answer. And don't forget your units. Okay. So you're going to get one question like this in the test. Okay, but it's exactly the same procedure. Okay, I think that's enough for today. Tomorrow morning between 9:30 and 10:30, I'm going to be available during the tutorial session for any more questions that you have. And then the test will then be available from 10:30 until 12. Okay, so that gives you 1 hour to write the test and then half an hour to scan your work and submit it. Okay, so the submission will be exactly the same as that tutorial test that you wrote. Okay, so you can submit PDFs, you can submit images. I don't mind as long as I get your work. Okay. And remember that the submission closes at 12. Okay, so you can't submit anything after that. Okay, if you have any more questions, please email me or post a message on the WhatsApp group. And also remember, we've got 2 new tutors now. So they are also available on the WhatsApp group and they can answer your questions as well. Okay. So if while you're doing your last minute preparations for the test tomorrow, remember that myself and the tutors are available for help. Okay. Okay, and then good luck for your test. I should have all of the test marking done by the end of Wednesday. So then you can see your results as soon as possible. Okay, bye everyone.
Bye.
Bye.